Okay, we're going to go ahead and get started. Hello, everyone. Welcome to tonight's presentation on green infrastructure. My name is Kristen Jansen, and I am an AmeriCorps member serving with Conservation Nebraska's Common Ground program. Conservation Nebraska's mission is to protect our state's natural legacy by educating the public, supporting communities, and increasing civic engagement, which we accomplish through locally led education efforts and community engagement projects to address local conservation concerns. Before tonight's speakers, there's just a few housekeeping things I'm going to go over. Your cameras will remain off and you will be muted throughout the presentation. So please type any questions that you have into the chat or the Q&A section, and we will answer those at some point during or after the presentation. This presentation will be recorded and will be uploaded to Conservation Nebraska's YouTube page within the next couple of weeks. So if you miss any part of today's presentation, would like to revisit any part, or to share it with others, you will be able to find it there. Following the presentation, we will have a very brief survey that should take only less than a minute to complete. This survey helps support programming like this one, so we appreciate you taking the time to fill those out. If anyone in attendance is interested in speaking with a Conservation Nebraska member regarding conservation issues in Nebraska, or to find out more about what we do, I will put our email in the chat and you can feel free to reach out. Tonight, we welcome Professor Steve Rodie and Dr. Richard Sutton, who are going to speak to us about green infrastructure. So I will let them take it away.
Well, let me start off here since I'm going to begin the presentation, welcoming everybody to the presentation. Steve and I taught a course on green infrastructure for several years, and he taught one, continued to teach it in Omaha. So what you're going to see tonight is just a fairly quick overview of something that we covered in an entire semester in class. So let's start with some definitions. Green infrastructure, that sounds like a mouthful, but they're kind of two basic definitions and they kind of overlap at different scales. You have a broad scale that talks about composition, makeup, organization, and relationships between the human and the built environments, which is green. And by green, I don't mean the color green, but it's sustainable and multifunctional and uses biological processes and materials. So that gives us a kind of a broad overview of what green infrastructure deals with. Specifically, though, on a smaller scale, say on a site scale or an individual project scale, uh, the designer must carefully select and use materials such as soils, plantings, topography, and fit that into the environment. And then the idea is to mitigate, constrain, deflect, direct natural features or natural processes like temperature, winds, storm runoff, sediment, visual intrusions, all those kinds of things that we see out there in cities and on sites. So I'm just going to run through kind of a laundry list here of the types of green infrastructure that could be thought about. First of all, windbreaks and screens. We Those have a big impact. You can just tell by the name. Windbreak allows the wind to be deflected or slowed down, and screening is another thing, but it's more of a visual aspect to use of plants. We also seen green infrastructure in just the use on our rural agricultural scene. Things like contours and grass waterways uh, are simply a way of adding structure, again, by manipulating the soil and the topography and the plantings to limit erosion. Our urban forests in our parks and along our streets have a big impact on not only the quality, but the quantity of temperature and runoff that we find in our communities. Soils, that supports plant life, but it also is oftentimes the major feature that feeds into runoff. And The stability of that soil is important along with its permeability. Pavements over that soil uh, change its permeability. So there are ways and techniques to use uh, materials to allow water to soak in more easily. Slopes oftentimes can move on us. Hopefully, you don't get a landslide, but creep will occur, and there can be uses of redirecting water, but also uses of plant material to start to mitigate that problem. If you have erosion, you're going to have sediment. And anytime you have exposed soil, it will be eroding either through wind or water or both. So it's important to be able to control the sediment that comes from erosion. And there are, again, wide range of best management practices and designs that allow that to happen. Streams have a habit of changing course and meandering and banks eroding, and that can be a real problem if there's nearby development that needs to be protected. Now, one way to deal with that is to come in and just armor it with heavy concrete and stone and so forth. But a more green infrastructure approach would be to use plantings such as willows and other kinds of riparian vegetation to control the stream bank meanders. Stormwater modeling and runoff, and Steve's going to talk quite a bit about this, and I'm actually going to show this graphic again when I talk specifically about green roofs. But this gets at the idea of trying to understand what happens to rainfall when it hits the surface. And this diagram shows a conventional versus a green roof, and I'll explain this a little more detail in a few slides. Bioswales, again, instead of sticking water or allowing water to run into just a concrete uh, channel, you can add plantings that will allow sediment to be taken out, but also cleanse and have maybe some biological activity on that runoff. Notice here, this is a good graphic to show multifunctional aspects. You're not only creating a bioswale, but you're also having an effect on a pedestrian walkway. Give it an edge, add some greenery and pleasantness. Water can be detained, and there are some real advantages to that because you get more biological practices occurring, although it does require uh, a fair amount of area to hold water. More commonly, we may find what we would call dry detention, and on a smaller scale, rainwater gardens. And again, Steve is going to go into some good examples of this a little bit later. And then I don't want to leave this out. It's not an actual green infrastructure aspect, although I guess those people could be considered part of that. You can't have green infrastructure without management and maintenance. It's not something you just put in and walk away from because there's living plants there. Things happen. They need to be replaced. They need to be mowed. It's just hopefully that they're done. The kind of maintenance that's done is at a much less intensive level than a garden. Okay, as I mentioned, I'm going to talk about green roofs in a little more detail. And Steve is going to go on and talk about and give some case study examples of the treatment train of water in an urban setting. Nebraska has a pretty long history with green roofs. If we think back to our soddies, they really had the ultimate green roof on them. Cut up some prairie sod and put it on there. Uh, Unfortunately, they didn't have the membrane systems that we have today, and those things often became kind of uh, dank and drippy during extended rains. Landscape architects have been using green roofs over structures for quite a while. Here are some developments from the 1950s where they used underground parking and covered it with green space with fountains and trees. And again, set in an urban situation, This is much more pleasant than looking at just a paved parking lot with a bunch of cars on it. And it also will absorb moisture and not create as much runoff. To really talk specifically and more recently about the history of green roofs, we need to go back to Germany. In the 1980s, Germany was starting to show some post-war urban decay. Uh, there was air pollution in the industrial valleys in Germany that was being turned into water pollution every time it rained, and that was a concern. They needed to deal with the runoff from these urban areas, so they had stormwater fees, but those things became somewhat onerous and needed to figure a way to reduce that cost. They came up with policies that dealt with some of the existing membranes, and I will give the Germans a tip of the hat. They kind of pioneered the whole idea of membraned roofs, particularly on flat roofs like we see in this graphic here. And they simply used very shallow media to ballast or hold down uh, the membranes, and those spontaneously sprouted vegetation. And so they thought, let's see if we can capitalize on this. They came up with tax incentives and subsidies and building requirements to even increase more green roof use. And from probably 1990 on up until today, you're probably looking at a 15 to 20% annual growth in green roofs in Germany. And 19 or 2023, about 50% of the new green roofs in Germany in urban areas were green roofs. So they're really making an effort to change how that hardscape, that building interacts with their environment in the urban settings. Let me run through a laundry list of benefits here, and I've already mentioned some of them, but let me put them in this list. Stormwater runoff is one of the major things because a hard surface roof will allow water to run off much more quickly. Uh, and it also changes the quality as well as the quantity of runoff when you put a green roof or a layer of substrate and growing plants to kind of serve as a filter or a valve on that roof. Once you get a green roof established and you have growing plants there, you've actually improved the biodiversity because you can grow plants there that normally would not be found in a city area. Normally, cities do not give large areas over to green space, and you can actually capture that on a roof. Once again, that the green roof is installed, it will dampen fluctuations, particularly through the ceiling of noises. It also improves the air quality because air blows across and will be filtered out. Again, certain plants do a better job. Grasses probably do a better job than some of the lower growing perennials. The typical roof membrane has to be replaced about every 20 years, and that ends up in the landfill. And by putting a green roof on that, you can extend it to at least another cycle, if not two cycles. So think about that. Instead of changing it every 20 years or replacing it, you can maybe get up to 50 or 60 years, and that material is not going into the uh, landfill at that time. Of course, with the cap of a green roof on a building, you're going to reduce the building heat and cooling loads. The air intakes on roofs will be pulling in cooler air so they don't have to cool it down as far. That saves money. And if you take that in aggregate across many, many buildings in an urban area, you can actually start to reduce the urban heat island effect, which can be significant in most urban areas. Improves the aesthetics. Here we are looking across at a green roof. That's much more pleasant to look at than simply a membrane with some air handlers sitting on top of it. The plants that grow on a green roof can actually hold and pull carbon out of the air, and that's a good factor. We see a lot, particularly in Europe and also starting in the US, the use of photovoltaic arrays on buildings. It's shown that they can really improve the amount of electricity that is generated if you have them in parallel with or on top of a green roof. So another little chart here that kind of pulls these things together, the benefits along the left side that I just detailed. But if we talk about the two things that are critical to a green roof, the substrate and its type and its depth, married with or in connection with the plantings, has an impact on all those things except perhaps waste diversion and solar placement. So we really, when we talk about green roofs, we have to deal with substrate and we have to deal with the depth of it. So here we are at the Pioneer Park green roof. Soon after it had been installed, the Pioneer Park Nature Center. And I circled here this dark area where the runoff from the green roof has this kind of murky brownish color. This is kind of a thing that green roof people don't like to talk about, but it's important because that runoff is very high in carbon, phosphorus, and nitrogen. And why would we want to leach those off of a green roof? We want to hold that on a green roof. And unfortunately, for the first few years, there's quite a bit of movement of that into the environment. And that's a problem. A green roof is built with what we call a sandwich layer. There are different layers based on different systems that are used, but has plants on top, growing in media that's over the top of in this case, a board that holds water in small little egg crate-like cups that then is again over a membrane that's over the insulation, then it's over the actual roofing structure. So that's a typical kind of, although they vary depending on the roof design, typical kind of sandwich. Um, when you hold moisture on the roof in those little egg carton type cells, that's great because it'll allow the plants to get water. But in the meantime, you're adding to the load on the roof. So that has to be compensated for by the structure. And after 56 hours, that water really becomes considered part of the structural load that has to be accounted for by the design engineer. Okay, back to this hydrograph here where we show what happens on a green roof. Rainfall coming out of the sky, and it's kind of a stair-step function because we're using collection buckets to measure it. It falls on a conventional roof, but there's a lag time between the time it first hits and when it starts to run off. If we put a green roof on, notice how the lag time extends out. Now that's important because that holds the water back and it doesn't all get to the local storm sewer at the same time, which tends to cause localized flooding. So you're not only cleaning the water, you're storing maybe a little bit of it in the media or in the egg carton-like cups, but you're cutting down the quick runoff for the roof. What about biodiversity? I mentioned that earlier. Does that mean that green roofs are going to kind of replace our urban habitats or our natural habitats in urban areas? Probably not. If we looked at primary productivity versus bird species, there's somewhere green roofs are somewhere just a little bit less than a grassland. but they can be designed to mimic our Great Plains prairies. So for a place like Nebraska, green roofs have some possibilities to allow some of our grassland birds to come and survive and thrive in town. Now, as I mentioned, substrate is an important component in green roofs. First of all, it ballasts or holds down the membrane. It has to have high transmissivity of water so that water moves through it quickly so that it runs off. It provides anchorage for plant roots, and it also provides plant water and nutrients. So it has a whole bunch of roles that it has to fulfill. You can't just design any green roof without spending some time thinking about the type of substrate and its depth. In fact, substrate really defines a green roof type. We have an extensive green roof with 3 to 6 inches of substrate, can only grow sedums and some bulbs and some very select grasses and forbs. Next, we have a semi-intensive green roof, which is maybe 6 to 10 inches. That means you can have those sedums and bulbs, but you can grow most of the forbs, and you can also grow some selected shrubs. So that gives us a little more plant diversity. More plant diversity, you have more animal diversity. And then finally, you have an intensive green roof, which really becomes the sky's the limit. You can grow trees, shrubs, what have you. And it's really considered to be more of a rooftop garden. Trees here, by the way, have to still have structural considerations from the structural engineer. So some design constraints that we run into when we're pulling the plants and the substrate together on the green roof is that for about every 1 inch depth of saturated expanded heat and shale substrate plantings, uh, you've got about 7 pounds. So if you get up to a 4 inch, you've got 28 pounds there that you have to deal with on your structural loads. Now, a heat expanded shale and clay makes up about 85% of the volume, air volume on a green roof. It fills up with water and then drains slowly out or roots pull it out. Now, when you're designing a green roof, you always have to balance between the substrate depth and the cost. And the cost goes up as the substrate goes up, the depth goes up. And so we want to have deep substrate so we can grow more diverse plants, but the deeper it goes, the more it costs. So you're always caught between a rock and a hard place in that design. Here's some older figures, but generally you're looking about half your costs of green roof are for substrate, a little, maybe somewhere around 12% or so for uh, the drainage layer. You also have some seeding and overhead and profit, like on any job, as well as some maintenance. You always have to balance these things out, but notice the cost, half of it is the substrate. So let me just share with you a little bit some of my research work. I try to focus on reducing the carbon, phosphorus, and nitrogen runoff from new green roofs by incorporating biochar into the substrate. It's been known to suck up and hold on to those materials, still making them available for plant roots. I design more biodiverse green roofs by thinking of green roofs as simple constructed prairies, increasing the depth of the green roof. Again, I'm caught between that hard rock, that rock and a hard spot, somewhere between extensive and semi-intensive. And then if you're going to have a prairie ecosystem, then you're going to need to cultivate the idea of a prairie aesthetic. These are not going to be nicely cleaned and maintained gardens. They're going to look more like a prairie. I looked at reducing costs by pioneering green roof seeding with native grasses as opposed to planting individual plants. Reduced the roof loading weights by using half losing half their weight by using recycled crumb rubber instead of the heat expanded shale and clay. Doesn't hold as much water, but you're still getting some interstices in between that holds water. And then reducing irrigation by increasing the substrate depth. And one that I think has a lot of potential is expand the market for green roofs because they're going to be lighter with the uh, uh, recycled crumb rubber onto existing roofs. You don't have to build up excessive structure to do that. And let me just quick go through a couple of case studies here. Here was the Pioneer Park Nature Center. And in approximately 1 year, we went from those plantings on the left to a fairly reasonable looking natural prairie-like setting on the right. Here's the Arbor Day Foundation green roof. That one was very tricky because it had a very thin profile because it was over an existing roof. Notice how my little plantings of prairie plants circled on the left held up a little better than the sedum did. The sedum lost all of its fancy form that was put onto the roof. It just didn't make it. Larson Building, again, showing some seeding in 1 year. What you got in terms of the native grasses basically filled the thing in. At the Sandhills Publishing, we looked at some different types of grasses, and it's interesting. You can get some very nice visual effects simply with grasses. Looking at the idea of different kinds of substrate, I worked with a EcoStore green roof where we use broken up concrete, or excuse me, broken up brick, mixed it with compost, and we were able to grow some forbs as well as some shrubs, a very small list of shrubs on this green roof. And then I worked with my construction class back in 2017. We actually used some of the crumb rubber on a green roof on East Campus, and that worked out fairly well. And then being someone who walks the walk as well as talks the talk, I used it on my own little workshop green roof and turned roofers into landscapers. And this was 2021. It completely closed in now. This is completely filled with native grasses and forbs. And then finally, some work I did with RDG Planning and Design for the new Durham Plaza at the UNMC. Uh, we used native plants there in fairly deep substrate. They had a fairly good load that they could carry on that roof. And we even got a few trees in there as well. So I'm going to turn it over to Steve at this point. Stop sharing.
Nope, we can't hear you.
Am I doing something I shouldn't be doing?
Nope, I think you're fine. It's just Steve's uh microphone isn't working again, it looks like.
Is Steve able to get on there?
Testing.
Yes, now we can hear you.
You can hear me and you can see my screen.
We get
All
rid
right.
of
Okay.
mine.
All right, Richard, thanks for the little bit of the intro. As Richard said, we both taught UNO, UNL. We both are registered landscape architects, have backgrounds in forestry and horticulture. So it's been a great career relative to teaching, but also working hands-on with a lot of these projects that incorporate plant materials and design. So as Richard mentioned, I'm going to talk about a treatment train, the idea in essence of trying to design to slow that water down as much as possible. Richard talked about trying to expand the time of just how long it takes for the water to either reach the sewer and or get the volume necessary to actually start treating water. And the slower that happens, the better we are in terms of infrastructure. This is Spring Lake Park. Oops, sorry. This is Spring Lake Park in Omaha. The interstate is kind of up at the bottom. This is south and west of the zoo and in the old Rosenblatt. So it's in East Omaha, and it's probably one of the best examples of treatment train and of one of the large CSO projects in Omaha that have been done as a combination of trying to do multiple best management practices and showing what that actually looks like and works like. So this is kind of a general map of the project, and you can see a variety of different pieces here. The watershed basically goes from the top left down to the bottom right. So there's an infiltration basin, there's a constructed stream that ties those together. There's a constructed wetland. Wetlands can be amazing for cleansing water, and the plants can uptake heavy metals. There's an infiltration basin, bioretention garden. The lake at Spring Lake Park is ultimately where the water ends up. It was literally designed to have really good fishing in it at this point, which was never the case earlier in the past when this was actually more of a dump. And then you can see some of the dashed lines. So there is storm pipes here, and it does go on and ultimately ends up down at the treatment plant and or into the Missouri River. But the context for this is that prior, all of this water basically ended up in our single sewer system in pipes, and there was no potential to actually slow that water down and use it effectively, like we've talked about earlier in the presentation. So this is a graphic that a colleague, Rocky Keene, came up with, a professional engineer, and this shows what happens in the Spring Lake Park neighborhood. The Saffel Baffle, that's the St. Anthony's lab where they do research on water on the Mississippi River up in Minneapolis. But the context for this is step by step, there are different features that hold onto the water. The Saffel Baffle initially takes erosion sediment out of what it goes into a sewer. The meandering channel slows the water down so that it can infiltrate. And then you work down to the constructed wetland we've already mentioned. Spring Lake Park also has a lot of benefit, obviously, both aesthetically, recreation, as well as water quality. Flat slope channels, so we don't get a lot of erosion. And then there was a splitting of storm pipes in terms of storm runoff and sanitary, so that was helpful. But the context for this, again, as I think you can see as we looked at those earlier graphics, the more steps you have in the process of getting the water ultimately to the Missouri River, the better chance we have of holding on to it, doing some good with it, and minimizing whatever treatment we might have to do with it as part of putting cleaner water into the Missouri River. So I have a couple of case studies here. They're different scales, but they're public. They're here in Omaha. Some of the guests may have already known of them or lived close by, but I think they're a good way to show how the treatment train works, but also different scales, different types of projects. So this is the Dundee Elementary Green Infrastructure Outdoor Classroom. The context for this, as it says, was to address multiple issues with a beautiful and functional landscape. So this is an overview of the school. So we're taking roof runoff from the north side of the building. There was the roof and the sidewalk both actually. There was a lot of erosion and water at the foundation of the building. This is the north side of the building, so it was shady to begin with. And then there were a lot of existing trees on site. So there's no grass growing. It was very muddy. It was a significant area that the school could use, but it wasn't that usable. And being in the north side, there was a lot of ice buildup in the wintertime with the steps. And then this driveway constantly had ice on it as well, given it was flat going out to the street here. So A lot of problems, and the context again was to try to not only solve some of the environmental problems, but also create learning spaces, really try to take more advantage of this school area and put it into more educational use. And then again, have it look good, obviously, for the neighborhood. So this is the north side. Again, very open. There were some tables out there, but not well used, especially in talking to the school folks. This was the start of construction, and you'll see here in a minute as we go through all the different pieces that were put in. So this is a big patio of permeable pavers that will infiltrate water and gave a much better area to have students congregate and to be actually a useful area that wasn't going to be near as muddy. So here's what the pavers look like. There's spaces that are built in between the pavers so the water can infiltrate down through the pavers. And that water then is collected and then routed back through a different direction. I'll show you in just a second on the map. So the whole context for this, again, is to treat water and manage water right where it hits the ground and then collect it and make a real slow process of that water getting off the site versus what it used to do. So again, you can see here's a swale. So the water is collected under the pavement. It goes across that sidewalk. And every opportunity is taken to slow it down and try to infiltrate it into what are fairly good soils in an older part of Omaha. This is about just north of Dodge on about 50th Street. Here's that area that had a lot of ice problems in the wintertime. Again, not well maintained at all. And historically, a lot of these older buildings had the storm pipes run directly to the sanitary sewer, which again means we have to treat that water as part of our sanitary sewer. So a lot of that was taken out, and then the water would end up in the street or across the property, which was a lot better way to helpfully clean up that water. So here's construction. There's more permeable pavement that was put in down here on this lower level. So again, you wouldn't have the icing and the flooding throughout the year. So here's what that pavement looks like. This is looking back. This is the kind of the lower area where there's a rain garden that kind of goes right through the middle, just above where those seats are. They had a green ash that emerald ash borer took out, so they were able to reuse those stumps as seating as part of again a group area. Let's see. This is down again towards the west end. This is another area. If you see the inlet there right at the bottom in the sidewalk. That took water off the sidewalk where we had those icy conditions. And then again, this routes the water over towards the stumps where all of that is collected and then ultimately ends up out in the street. We even had an additional cistern put in. So you can see, so the roof runoff, instead of going straight into the old sewer pipes, now runs either into the water under the patio, which is collected, or it runs into the cistern. So we have a way to water plants out there. So this is an overall diagram to kind of show that. So we're looking north as to the top here, and I put the blue arrows in to kind of show all the different routes that the water takes in terms of ultimately getting out to the street there on Chicago. So again, a much less direct route for all of the water. So this is again picture one, picture two. We've seen some of these before, but I just highlight them on the base map then to kind of show where each of these occurs and which direction you're looking at to be able to see what the management practice looks like. So 3 and 4, we've got a little bit of a rain garden with interpretive signage out there to help people understand just how complex this landscape really is and how much work it's doing with the rainfall to help clean the water and slow it down. This gets down again to that area on the west. There's a couple of rain gardens out here that infiltrate the water. You should never have water in a rain garden more than about 24 to 48 hours. So we are detaining, we're definitely not retaining water in a rain garden. But there's always an overflow. So if it overflows, then it continues on the path, as you can see here with the blue arrows. And then ultimately water down at the bottom. And then that top right photo, number 8, shows what's a smaller rain garden right at the very end where the curb is. And then that curb cut is the ultimate endpoint where the water comes out into the street and ultimately joins the street runoff. So quite a journey for that water coming off the roof or the pavement to be able to get through the site. And again, all of that slowdown makes a huge difference in water collecting in the storm system and then having to manage a much larger volume. Wetlands and bioswales. This is a project over in Council Bluffs. This is the Bass Pro Shops. I'm sure a lot of people know where it is. It's right next to I-80. But I don't think a lot of people realize that this entire site is an excellent example of a stormwater management landscape. So, oops, I'm sorry. Go back here. If you look at the dark arrows on here, there's no curb and gutter in any of these parking lots. It was designed for the water to actually run off the pavement into the swales that you see that are parallel with where the cars park. And so all that water runs off. You can imagine the cost savings not to have to put in the 6-foot curb to keep the water going into storm drains. All the water ultimately then ends up down at the lower right corner of the site where there's a wet depression, wetland type area. If that overflows, then it actually goes into the Council Bluffs storm sewer. And you can imagine in a floodplain city like Council Bluffs with the Missouri River levied, that the less water they have to deal with in a huge rain event going into their storm system, the better. So they were elated to have this and minimize all that runoff they would have had otherwise from the parking lots and the roof of the building into their storm system. In the meantime, all of these swales look very natural. The wetland at the lower right there looks natural. It's almost it's a great setting to have a Bass Pro Shop. I think it looks very natural. Perfect kind of a marketing framework for what that building looks like as you drive by on the interstate. So a lot of win-win on this project. And then I worked on the Community Engagement Center rain garden at UNO. So this is kind of the center of campus. We had a location on campus that had some mulch and some trees. Nothing was working well. A lot of plants had died there and replaced numerous times. So in this particular area, that blue arrow shows where the watershed was. We had water running down the sidewalk. If you look at the picture on the upper left, you can see the mulch washing out. It ends up in the street and then into the storm sewer. So if you look at the lower right picture, you can see the water that we could collect and then potentially put in that approximate rain garden area. So was it necessary? Was it a safety issue? No, but it was an opportunity to put some green infrastructure into campus, put in some native plants, and take advantage of the fact that we had that runoff and otherwise it was just going into the storm sewer. So this is what the existing condition looked like. So again, mulched area, very poor drainage. The bald cypress you see here that are native to the swamps in Louisiana actually did well once they replaced many other species that died because of the poor drainage. And then this was, I think this was year 2. So it doesn't take long, as Richard showed on the green rows, for these plants to really fill in. That feature in the foreground is a forebay. So that would help pull sediment out of the flow off the sidewalks, that you can get a lot of sediment even on concrete surfaces. And then the swale itself goes through over, the overflow is right by that light pole. So if anything overflows here, it goes across that driveway into a storm drain, which is where it all went before anyway. But now we're using some of that water. And I taught plant ID at UNO, and we had a really great cross-section of native plants we wouldn't have had on campus otherwise as part of this garden. You can see the butterfly milkweed in here. There's some liatris, coneflowers. So again, a lot of habitat diversity that wouldn't have been available otherwise when you look back at that picture that just had the mulch in it. And then when you design these landscapes, you have to think year round. So there's a lot of stuff that gets cut down first in the spring, but the notion of winter color and texture, the bald cypress are deciduous, even though they're conifers. So they have a nice rust red, rust orange fall color. But the context of this is that 12 months a year. And it can be a challenge to design these gardens with a lot of perennials and forbs and grasses and have them look good a big part of the year. But that's part of the challenge, it's part of the fun of designing these. And then this is some backlit butterfly milkweed and little blue stems. So there's an incredible amount of beauty in the native plants that we can put in our landscapes. You've got to kind of get your nose in them to see them. But the subtleties are there. And again, this is into the wintertime when, quote unquote, a lot of us think there really isn't much to look at in a landscape. So it's important. And then that butterfly milkweed seed, some of the students actually collected that and were growing butterfly milkweed in the greenhouse. Creighton Prep is one more. It's over on 72nd Western. Huge project at the high school. The city put in major funds here as part of a demonstration project. This is what it was initially. So that storm grate you see down there at the bottom handled all the water from the parking lot. You can imagine how polluted that water was. All the runoff from the athletic fields up to the upper right, and basically ran across the turf and in. This went to Coal Creek, which has historically been a real flooding problem for the city of Omaha. So anything we could do to slow the water down here, again, is going to help Coal Creek. So this is what the rain garden looked like in 2016. This is actually by our attention, since we do have an under drain in this one to make sure that it does drain. But the context for this is what the asters look like in the fall. So you get a lot of fall color with goldenrod and asters in these gardens. So again, a lot of aesthetic beauty here, but a lot of time for that water. And again, with all of that parking up above, this garden being able to cleanse that water before it gets to Coal Creek is a major benefit. So just a couple, that's kind of an overview. I guess I would say one more thing in terms of defining green infrastructure is that our profession is taught to try not to mess it up in the first place. And when I say that, nature has an amazing ability to manage stormwater. It always has. And so having a large tree canopy is a stormwater maintenance and management tool. Good soil manages runoff. So part of the challenge, I think, oftentimes with development is to save what's good and not think that if we're going to put in something brand new, somehow have it figured out better than nature would in terms of how nature would manage it. So if we do need to replace, if we can emulate nature, as Richard talked about with the prairie plants on a rooftop versus sedums, then there's a lot more multiple benefit that we can derive from some of these projects. So I did want to mention, I don't know how many people on here might be interested in a rain garden as part of the scale that you can do in a home setting. And I think, Kristen, you may have already had a workshop or will, but this is I wanted to mention this. This is a rain garden PDF that I worked on at UNL that is, I think, an excellent tool for site design selection. It's an interactive PDF that you can still get access to at UNL. The website is down below there. But if you're really interested in wanting to start from scratch with a rain garden, whether it's measuring your roof, measuring your area, what kind of soils do you have, it's a good place to go as a resource. And then this is a plant guide that I worked on with Andy Zotko at the city of Omaha. So that's the other big question oftentimes in these gardens. We mentioned a lot of plants today, or at least showed them. So you got to get the right plant in the right place when you design green infrastructure. So there are some really good, useful resources in Omaha with UNL, with UNO, and the closer the better when you're working with plants in terms of making sure they're successful in these gardens that are designed. So that's all I have. So if there's any questions, it'd be a good time to cover them.
Yes, I'm going to go ahead and launch the survey if you would be willing to take that. And we did have a rain garden event that happened a couple of weeks ago that should be on our YouTube page. So if anybody's interested in like backyard rain gardens, that's specifically what she focused on, was like how to create one in your own yard instead of like a commercialized setting. So you can look at that. She talks about different plants and stuff as well. And then also if anybody's interested in kind of seeing a rain garden and getting some hands-on like work, we are doing a rain garden event at Creighton Prep, which Steve talked about, on June 11th at 6:30. So if anybody is wanting to volunteer to kind of help with a rain garden, we are doing that as kind of a cleanup for them. So if anybody has any questions, you can go ahead and put them in the chat. Richard, I think you're gonna have to unmute yourself. Let's see. It should be on the lower left-hand side.
Sorry. Got it.
You're good. I did have a question about like your personal rooftop. Yeah. How deep is your substrate for your green roof?
All right. So let's use my workshop as an example. Um, It has a crown on it that is 9 inches deep, and it tapers to the side that's 6 inches. So you can it averages 7.5 inches, and the weights were well within easy to be handled. I've got a table where I can pull the weights out. I don't have them off the top of my head, but uh, it was much lighter than it would have been with a typical heat expanded shale and clay. And with the deeper media or the deeper substrate, then the prairie plants seem to do a little bit better.
Yeah, thank you. I was curious about like how deep you personally made it since you talked about like the different depths and what those can kind of do. So yeah, that's kind of cool.
So was that a question?
So there's a question that says, Steve, can you put the link to the publication in the chat so that they can just click on it?
Yeah, should be able to, let's see. I'll put the other one, I'll put the see, do I have the plant guide? I don't have the plant guide one, but it's on the Omaha Stormwater website. And so I think if you Googled that, you might be able to get close to it. I should have put that one on this slide too, and I don't have it on there.
And I will send a follow-up email to everybody who is registered. So if you get that, I can send it out with that as well. So
Okay, I'll do that. There's again, it's some of these have been, I think the plant guide is probably 10 years old at this point. When the city was trying to come up with a lot of demonstration projects to show how this stuff worked, like Creighton Prep and others, we did a lot of this work to help. So there's always going to be new plants for sure, the latest and greatest. But I think for the just the standard what works where, these guides work pretty well. The rain garden design is pretty universal. So, but I'll be happy to send you that, and then you can send it out.
yeah, perfect. I will send out a follow-up probably sometime next week. That just will have some additional information. I can include those links in there just so that everybody can have those and keep them for their records. So if there aren't any other questions, then I will just go ahead and end the webinar. Thank you both so much. This was really interesting and I learned a lot about it. So,
All
Thank
right, good
you,
luck.
Kristen.
all right, thank you.